Hello everyone. I hope you all are good or must be hope. And I also hope you all must have attempted the test. किसी ने ऐसा तो नहीं किया कि टेस्ट में गए ही नहीं और गए तो सही से किए नहीं. No. I hope आप सबने किया होगा. And in this video, we are going to basically discuss important questions. Questions where I feel you might have done mistake or where I feel like some concepts are there which you should know for sure. Done. So those sort of question I have picked. Now let's get into the question. Okay. So the very first question is the very first question of your AIET test 1. है ना? तो चलो. What the question is, when calculating the flux of electric field over the spherical Gaussian surface, the electric field will be due. Now, what is this Gaussian surface? So, this Gaussian surface is nothing but a part of Gauss's law. Gauss's law क्या है? उन्होंने ये कहा था कि flux through the closed surface is equal to charge enclosed in the surface by epsilon. Now, this closed surface meaning, again remember, closed surface का मतलब होता है 3D surface. Done. And Q enclosed का मतलब whatever charge is inside the surface. So suppose this is a hollow sphere here, and charge inside is plus Q1 minus Q1. So flux and outside charge, you can see there is one charge Q2. So flux will be because of only the charge which is inside, that is plus Q1 and minus Q1. And if we are going to add these two, क्योंकि total inside charge कितना हो जाएगा? Q1 minus Q1. So flux is going to be 0 here now. But the question is different. Question ये है कि when calculating flux of electric field over the Gaussian surface, electric field will be due. So flux is only because of charge inside, but electric field will be because of all the charges, whether it is inside or outside. How? जैसे देखो Q2 चार्ज को आप ले लो, this is a positive charge, so from it electric field will come out like this. So you can see here clearly this electric field line is entering at this point 1 and exiting at this point 2. So whatever field number lines will enter will exit also. So net flux because of this charge Q2 will be 0. But if you have to calculate electric field at this point inside the surface, suppose, so because of plus Q1 inside charge, it will be like this. And because of this minus Q1, it will be like this. And if I take a field line coming from Q2, we will draw it something like that. So yes, flux because of this field line is 0, but it is contributing to electric field here. Right? So electric field will be because of all the charges. Please keep this in your head. ये बहुत important. Done. Now this thing I also discussed in the class. यहाँ पे electric field lines दिया हुआ है. Two charges are there, Q1 and Q2, and we have to compare their magnitude. So I have told you if magnitude is higher, more number of electric field lines will come out of that. Here, more number of electric field lines is coming from Q1, not from Q2, क्योंकि आप count कर सकते हो. जैसे यहाँ 3 हुआ, ये 3 हुआ, 6, 7, 8, 9, 10, 11, 12, 13, some 13 lines. And from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, only 9. This is 13. So definitely Q1, magnitude of Q1 is greater than magnitude of Q. Okay. So the correct answer will be what? A. Now, this is a question to charged spherical conductor of radii R1 and R2. हमारे पास दो spherical conductors है. Remember, these are conductors. ठीक है? And their radius are R1 and another radius is R2. ठीक है? They are connected by wire. Then the ratio of surface charge density. Now, what is the significance of these two conducting spheres connected by wire? When we connect two conducting things together or through any conducting thing, जैसे यहाँ पे वायर है, तो उन दोनों का पोटेंशियल क्या हो जाता है? सेम हो जाता है ना? Potential will be same. जैसे आप ऐसा कुछ ले लो, suppose this is a metallic sphere, it has charge Q, and there is another metallic sphere, it has charge 4Q. Suppose कर लो दोनों का radius same. ठीक है? So what is the potential on the surface of this sphere? Potential का formula you know, KQ by R. What is the potential here? It is K 4Q by R. Done. So potential of this surface is higher than that of this. If we are going to connect these two, their potential has to be same. But for that, what will happen? Charge will flow from here to here in such a way that their potential will become equal. Done. So potential has to be equal if they are connected. Now, if potential is equal, then sigma 1 by sigma 2 is here in the case. So on this surface, charge density is sigma 1, and on this surface, charge density is sigma 2. So just calculate the potential. So potential formula is what just now I have written. So for this surface, it will be K Q1 by R1. But Q1 is not given, sigma 1 is given, but we can calculate Q1 now. Q1 value will be how much? It will be sigma 1 into 4 pi R1 का square. ठीक है? So this will be equal to K Q2 by R2. Now simply write those things. K into Q1 का value आप क्या लिखने वाले हो? Sigma 1 into 4 pi R1 square divided by R1 equal to क्या लिखोगे? K into 4 pi sigma 2 4 pi R2 का square into sigma 2 divided by R. ठीक है? So what answer we are going to get now? If we are going to cut things, so 4 pi will get cancelled, k will get cancelled, 1 R1 will get cancelled here. Similarly, here 1 R2 will get cancelled, and what we are going to get? Sigma 1 R1 is equal to sigma 2 R2. So sigma 1 by sigma 2 is equal to R2 by R1. So the correct answer will be what? Correct answer should be B. ठीक है? चलो. Now again, this is the question. क्या क्वेश्चन है? There is a charge 10 microcoulomb is placed at the center of a hemisphere of radius r 10 centimeter. The electric flux through the hemisphere. Done. Now we can easily calculate electric flux here by using Gauss's law. Gauss's law हमारा क्या कहता है कि electric flux through closed surface is equal to Q enclosed by epsilon. ठीक है? बट हियर वी नीड टू यूज इट वेरी वाइजली. जैसे अगर आप ये देख लो कि सपोज कर लो ऐसा कुछ क्यूब है, वी यूज सिमेट्री ना, एंड हाउ व्हेन वी यूज सिमेट्री, अगेन दैट्स द क्वेश्चन. So if there is a cube and we have kept the charge at the center, if charge is at the center, then we can say that a cube has 6 faces, right? So if charge Q is kept at the center, this cube is a closed surface. So flux through the whole cube is how much? Q by epsilon naught. Now if question is to calculate flux through any one surface, then we can easily say that since charge is at the center, through symmetry, each surface will receive equal flux. यानी कि 6 surface receiving equal flux will add up to Q by epsilon naught. So each surface will receive flux how much? Q by 6 epsilon. Why we are able to use the symmetry here? क्योंकि charge हमारा center पे है. अगर हमारा charge center से थोड़ा सा भी इधर होता, कहीं भी some distance right or some distance left, तो we couldn't have used first thing, है ना? But if charge is at center, we can use that. यहाँ पे देख लो आप, हमारे पास this is hemisphere and the charge is kept here. So flux coming through electric field lines coming through this charge will look something like this, also like this. So if we want to calculate electric flux through Gauss's law, how we will use that? So simply we will cover it. And we will say that through this total solid sphere or hollow sphere, flux will be how much? Flux is going to be how much? Q by epsilon naught. So through the half, how much flux will be there? Q by 2 epsilon naught. क्योंकि in the question it is asked flux through the hemisphere, यानी कि half of the solid sphere. Done. So Q by 2 epsilon. अब आप values put कर दो. Q का value is given how much? 10 into 10 to the power minus 6. Epsilon naught का value क्या होता है? 8.85 into 10 to the power minus 12. Now if you are going to solve it, how much it will become? 10 to the power minus 5 ये है, ये 10 to the power minus 12 है, तो 10 to the power minus 7 नीचे बचेगा, जो कि जब ऊपर जाएगा तो it will become 10 to the power 7 by 9 we can say, and we can write it like 100 into 10 to the power 5 by 9, है ना? और हाफ करना होगा, सॉरी हाफ नहीं किया, Q by epsilon नॉट सिर्फ लिखा है मैंने. तो this into 2, 100 by 18, so it will come as something 5.5 into 10 to the power 5. ठीक है, तो 5.6 into 10 to the power 5 near about. Done. So that answer we are going to get. Now again another question. Three concentric metallic spheres ABC have radius ABC and surface charge density is given है. हमें निकालना क्या है? A के स्फीयर के सरफेस पे पोटेंशियल क्या होगा and what will be the potential on the surface of B. This thing we have to calculate, right? Now remember this is a metallic sphere, first thing. Done. And second thing, charges are not given, surface charge densities are given. So what are the important things that we need to keep in our head while solving this question? पहली चीज ये है कि if there is a metallic sphere, be it solid or hollow, doesn't matter, whatever charge is given to it will rely on the surface. तो सबसे पहली चीज तो कि चार्ज मेरा सरफेस पे होगा. Second thing, if it is a metal, then whatever potential is at the surface, same potential will be everywhere inside, है ना? And at any distance r outside the sphere, potential formula will be how much? Kq by r. And at the surface it will be equal to kq by radius, and the same value of potential will be inside at any point, है ना? तो चलो, लेकिन यहाँ पे surface charge density दिया हुआ है, तो let's write this q in term of what? Surface charge density. So surface charge density is sigma, then q can be written as what? Sigma into 4 pi. चलो मैं कोई भी जनरल के लिए, सपोज इसका रेडियस कैपिटल आर है तो 4 पाई आर, तो मैं यहाँ पे लिखती हूँ k इंटू क्यू को क्या लिखेंगे? 4 पाई आर स्क्वायर इंटू सिग्मा डिवाइडेड बाई आर. के को ब्रेक कर लो आप, 1/4 पाई एप्सिलॉन नॉट 4 pi r square sigma by r. 4 pi got cancelled, and what answer we are going to get? Sigma r square by epsilon naught r, where r is the small r is the variable distance. मैंने ये इसलिए लिखा, फॉर्मूला तो kq by r है, since sigma is given, so let's write it in the term of sigma, so that when we are going to solve it, we will directly use this form, है ना? तो चलो, now let's calculate potential on the surface of A. So what will be potential on the surface of A? क्या होने वाला है आप बताओ, क्या होगा? सिंपल है. So on the surface of A, potential will be because of a sphere A, B, C. So let's take any point on the surface of A. I have denoted it by red point that is here. So since this point is on the surface of a sphere A, potential because of charge on the sphere A will be how much? Sigma r square by epsilon naught. Small r का value क्या डालूं? Since it is at the surface, its radius is how much? Its radius is a. Done. तो यहाँ पे भी a लिखना होगा मुझे. And since at a distance we are calculating, तो यहाँ भी a लिखना. ठीक है. Now let's calculate potential at this point because of a sphere B. So this point is inside a sphere B. So whatever potential is at the surface of B because of charge on it will be the potential at any point inside. So what will be potential at the surface of B because of charge on the B? क्या होने वाला है? Charge negative है तो negative potential होगा. Sigma radius of B is equal to how much? B square, and we are calculating at the surface. So small r will also become what? B. Done. Again for C we will be because of C we will see ki what is the potential at this point at the surface of A. So again this point is inside a sphere C. So whatever potential is at the surface of C will be at any inside point. So C पे कितना charge density है? Sigma. So again let's write it, sigma C square by C. So what will be the answer here? If you can, sigma by epsilon naught को आप common ले लो, a minus b plus c. So VA we have already got. Now let's calculate VB. So let's take any point there on the surface of B. तो चलो मैंने ये यहाँ पे एक point लिया ये. So because of A, potential at this point will be how much? This point is outside sphere A. So potential at point P ले लो, इसको P मान लेती हूँ मैं, लेकिन B दिया है क्वेश्चन में, B ही मानते हैं, ठीक है. So potential at point B will be how much? Because of A, तो लिखते हैं सिग्मा ए स्क्वायर बाई एप्सिलॉन नॉट, स्मॉल आर का वैल्यू यहाँ पे क्या हो जाएगा, बी, तो आप डी लिखो यहाँ. अगेन this point is on the surface of B, so potential will be same as that is on its surface, so same पहले जैसा लिखेंगे. और again this point is inside a sphere C, so because of a sphere C potential will be same as that is surface, so sigma C square by C. So what is going to be the answer? Sigma by epsilon naught B square by A minus B plus C. So in such type of question, what you have to do, you have to calculate potential at any point because of all three spheres. And you have to see if that point is inside all three spheres or is it outside for some and inside for some. Accordingly, you have to write the form. Okay? So answer here will be which? A. Then again, this question was very easy. Very easy. What you needed to tell here, you needed to tell कि किस point का potential का relation क्या होगा. So there is one line that you need to remember, and this line is very, very important. So many questions come even in G and NEET both. Then, and that line is what? In the direction of electric field, in the direction of electric field, potential decreases the highest. तो अगर इलेक्ट्रिक फील्ड का डायरेक्शन इधर है, इट मींस as you will move in the direction of electric field, potential will keep on decreasing with a maximum rate. Done. तो आप यहाँ पे देख लो इलेक्ट्रिक फील्ड का डायरेक्शन दिया हुआ है, सो इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड पोटेंशियल विल बी लेस. सो देखो ए पॉइंट इज हियर, बी पॉइंट इज हियर, सो ए एंड बी पॉइंट आर एट द सेम लेवल ऑफ इलेक्ट्रिक फील्ड, है ना. Not one is ahead, not another is behind, at the same level, है ना. तो potential of A will be equal to potential of B. Now D is more towards the direction of electric field and C is behind it, है ना. D क्या है, इलेक्ट्रिक फील्ड के डायरेक्शन में ज्यादा है और C उससे पीछे है, यानी कि D will have less potential than C because in the direction of electric field potential keep on decreasing. It means as you are moving from C to D, what is happening? Potential is sharply decreasing. So potential of C will be greater than potential of. This is the thing. So again, this question was very much easy. ठीक है, चलो ये क्वेश्चन भी बहुत डिफिकल्ट नहीं था, बहुत ही ज्यादा इजी है. क्वेश्चन क्या है? A thick metallic spherical cell of inner radius R1 and outer radius R2 has charge plus Q. ठीक है. Just now I have told you कि whatever charge you are giving to the metals, that will reside on its surface only. So यहाँ पे thick metallic sphere is given, ठीक है. Its inner radius is something, outer radius is something. मतलब metal material is present in this space. This space is hollow, है ना. So whatever charge we are giving in this space, this is a metallic space, right? So that charge will not stay inside, that will go on its surface. So whatever charge we have given to this, how much charge we have given, plus Q, so that plus Q will reside on the surface. First thing. Second, यहाँ पे एक और twist है. Twist is that कि we are keeping a small charge Q at its center. Then now what will happen to this? So for that let me draw another diagram. So आपने पढ़ा है कि जो metal होता है, metal के अंदर electric field used to be what? Zero. No electric field can exist inside metals, and इसीलिए whatever charge you are giving to the metal, that is going on its surface, है ना. ये चीजें आपने पढ़ा होगा. तो चलो, Q is here. Done. So if this is a positive charge, this is a vacuum area, what will happen? Electric field will come out of it. But the thing is what? Thing is that this space is what? This space is a metallic space. This electric field coming out from the positive charge won't be able to cross this area. क्यों? क्योंकि ये एरिया बिल्कुल खाई है. जैसे you are crossing, suppose you are walking somewhere and there is a khai in between. Khai means there is a valley, a deep valley in between. तो आप चल नहीं पाओगे ना. अगर there is not any bridge, you won't be able to cross it, right? कुछ ऐसा ही यहाँ पे. This is a deep valley. It can't cross like this, and there is no bridge as well. तो क्या होगा? तो यहाँ तो वो नहीं जाएगा, लेकिन फिर यहाँ किसी तरह दिखेगा ऐसे, कुछ ऐसा. अब आप देखो, यहाँ पे इलेक्ट्रिक फील्ड लाइंस ऐसा लग रहा है कि इट इज कमिंग फ्रॉम पॉजिटिव चार्ज, इट इज एंडिंग हियर, इट इज एंडिंग हियर, एंडिंग हियर, एंडिंग हियर, एंडिंग हियर, एंड अगेन कमिंग आउट फ्रॉम. How it is possible? It is only possible like positive charge comes out of sorry, electric field comes out of positive charge, end on the negative charge. If it is ending at this point, it means here negative charge is there, है ना? And if it is again coming out from here, it means positive charge is on the surface. मेरे कहने का मतलब ये है कि if there is a cavity inside and this is a metallic space, and if in the cavity we have kept the charge, look at carefully, if in the cavity we have kept charge, this is a positive charge, it will attract free electrons of the metal, है ना? So these free electrons will get assembled here, and if negative charge it is attracting, it will repel positive charge. And how long it can, like to what distance it can repel positive charge? Positive charge can go maximum up to the surface, क्योंकि ऑब्जेक्ट छोड़कर तो नहीं जाएगा. So what will happen? Minus q amount of negative charge will reside on its surface, and plus q amount of positive charge will go on the surface, and that is why electric field will look something like this. देखो पॉजिटिव से निकला, नेगेटिव पे एंड हो रहा है, ठीक है? So मेरे कहने का मतलब ये है कि if we are giving a positive charge in cavity, this positive charge will also appear on the surface, and also extra positive charge plus q we have given in this space, that also will appear on the surface. So how much total charge is there on the surface? Q plus q. What will be the surface charge density? Q plus q by 4 pi, इसके radius का square, so that radius is 4 pi r2 का square. So this will be surface charge density. So C is going to be the correct answer. Okay. So that is how you deal with cavities and charge kept in cavities. Okay. चलो. So again, ये question भी बहुत easy है. Only you need to read it, remember a formula and answer. जैसे यहाँ पे equipotential surfaces दिया हुआ है. And you have to tell that which point has maximum field intensity and which point is minimum. यानी कि where electric field is maximum and where electric field is minimum. कैसे करोगे? You all know one formula, that is E equal to VD, है ना? If electric field like here, जैसे main formula क्या है? dV equal to क्या लिखते हो? dV equal to लिखते हो minus E dot dl. तो मैंने यहाँ पे क्या किया, सिर्फ मैग्नीट्यूड वाइज लिखा है. मॉड्यूलस ऑफ इलेक्ट्रिक फील्ड को मैं क्या लिख सकती हूँ? सॉरी, मैंने गलत फॉर्मूला ही गलत लिखा है, सॉरी. सो इलेक्ट्रिक पोटेंशियल डिफरेंस के मॉड्यूलस को मैं क्या लिख सकती हूँ? अगर इलेक्ट्रिक फील्ड और डिस्प्लेसमेंट सेम डायरेक्शन में है, अगर इलेक्ट्रिक फील्ड और डिस्प्लेसमेंट सेम डायरेक्शन में है, तो डीवी के मॉड्यूलस को क्या लिख सकती हूँ? ई डी, वेयर डी इज द डिस्टेंस, ठीक है? डीएल को मैंने डी लिखा है. डन. सो पोटेंशियल डिफरेंस कैन बी रिटन एज व्हाट? ई इनटू टी. अब आप यहाँ पे ध्यान से देखो, देयर आर हाउ मेनी इक्विपोटेंशियल सर्फेसेस? ये सर्फेस है, इट्स पोटेंशियल एवरीवेयर इज 40 वोल्ट. एक ये है 30 वोल्ट, एक ये है 20, एंड दिस इज 10. हमारा जो पॉइंट आर है, दैट इज हियर, पी इज हियर, क्यू इज हियर, सॉरी, पी इज हियर, क्यू इज हियर. डन. So point R is lying in between these two equipotential surfaces. अब आप ध्यान से देखो, in these two equipotential surfaces, potential difference is how much? 40 minus 30, that is 10. Between these two potential difference is how much? 10. यहाँ पे भी 10 है, यानी कि हर equipotential surface के बीच का potential difference is same, that is 10 volt. What is changing here? सेपरेशन बिटवीन इक्विपोटेंशियल सरफेस इज चेंजिंग. यहाँ ज्यादा सेपरेशन है, यहाँ कम है, यहाँ उससे भी कम. डन. सो दिस डी थिंग इज चेंज. नाउ इलेक्ट्रिक फील्ड विल चेंज देन, सो ई विल बी इक्वल टू डीवी, दैट इज 10 एवरीवेयर, डिवाइडेड बाय डी. सो टू फॉर इलेक्ट्रिक फील्ड टू बी मैक्सिमम, डी शुड बी मिनिमम. वेयर डी इज मिनिमम? यहाँ. और यहाँ कौन सा पॉइंट लाई कर रहा है इन दोनों के बीच? पी. सो पी विल हैव मैक्सिमम इलेक्ट्रिक फील्ड and R will have minimum electric. So the answer will be what? It should be P. ठीक है? तो सिंपल. डन. अब आप यहाँ पे देखो, एक क्वेश्चन है, the velocity v acquired by an electron starting from rest and moving through potential difference P is shown by which of the following graph? Again, I have told time and again, please yaar, get comfortable with drawing equation of parabola, equation of a straight line. ठीक है, जब भी आप equation of parabola पढ़ोगे और रिवाइज करोगे, प्लीज मेक श्योर कि यू नो हाउ टू ड्रॉ अपवर्ड parabola, डाउनवर्ड parabola, साइडवाइज लाइक दिस, साइडवाइज लाइक, ये चार चीज को अगर तुमने याद रख लिया ना, ग्राफ का टेंशन तुम्हारे दिमाग से चला जाएगा. सो प्लीज डू दैट. नेक्स्ट टाइम व्हेन यू गो टू अपीयर फॉर द टेस्ट, प्लीज रिवाइज just drawing these graphs. Done, and that will take hardly your 20 minutes, I'm telling you. तो सेम यहाँ पे है, देखो, the velocity v acquired by an electron. जैसे हमने एक चीज पढ़ा है कि if q charge is thrown और इज सपोज कर लो एक रीजन है जिसका पोटेंशियल डिफरेंस भी है, यानी कि प्रीवियस क्वेश्चन में ही अगर ऐसा ऐसा था, पोटेंशियल डिफरेंस वाज यहाँ पे 30 था, यहाँ पे 40 था. सपोज आई एम सेंडिंग अ चार्ज लाइक दिस, इस रीजन में मैंने एक चार्ज को थ्रो कर दिया, तो व्हाट विल हैपन व्हेन वी थ्रो अ चार्ज इन अ रीजन ऑफ पोटेंशियल डिफरेंस, चार्ज गेट एक्सेलरेट. ठीक है, चार्ज क्या होता है, एक्सेलरेट होता है. डी एक्सेलरेट भी हो सकता है डिपेंडिंग ऑन हाई से लो पोटेंशियल जा रहा है या लो से हाई जा रहा है. ठीक है, दैट विल डिपेंड ऑन. बट यहाँ पे एक्सेलरेट हो रहा है क्योंकि माई इलेक्ट्रॉन इज इन रेस्ट and gradually it is picking up velocity v, so it's getting accelerate. Now if we accelerate a charge q through potential difference v, then energy acquired by the charge is written as qv. पढ़ा होगा तुम लोगों ने, energy acquired is q into v. What kind of energy is this? Kinetic energy. Here v is what? Potential difference. q is what? Charge value of that particular particle. This is kinetic energy. Kinetic energy को क्या लिखोगे? Half mv square, and this is equal to q into potential difference. We have to draw the graph between velocity and potential difference. तो आप यहाँ पे देख लो, velocity किस एक्सिस के अलोंग है? y एक्सिस के अलोंग है ना? और पोटेंशियल किस एक्सिस के अलोंग है? x एक्सिस के अलोंग. तो यहाँ पे आप क्या लिखोगे? y square is equal to some constant k into x. कुछ ऐसा ही ग्राफ आ रहा है ना, v की जगह मैंने y लिखा है, पोटेंशियल की जगह x लिखा. ठीक है, सो दिस इज नथिंग बट इक्वेशन ऑफ पैराबोला. ठीक है, एंड दिस इज इक्वेशन ऑफ अपवर्ड पैराबोला. ठीक है, तो यहाँ पे हमारा करेक्ट ग्राफ कौन सा होगा? इट विल बी दिस. क्योंकि एज जैसे यहाँ पे इस ग्राफ में क्या है, एज पोटेंशियल इज इंक्रीजिंग, velocity is increasing but it is becoming constant. ऐसा नहीं होगा. If potential difference is increasing, kinetic energy will keep on increasing. ठीक है, तो kinetic energy हमारा क्या होगा? Increase करता रहेगा. So that is true here only. ऐसे भी बता सकते हैं. ठीक है, so the correct answer will be what? Correct answer will be B. चलो, now again this is a question from mechanics. There is a spring balance and that is attached to the ceiling of the lift. A man hangs his bag on the spring and the spring reads 49 Newton. सबसे पहले तो ये है कि spring balance is what? It is a weight measuring instrument. How it measures weight? Whatever tension we get in the spring balance, that is equal to the weight measurement. ठीक है, तो spring balance will look something like this. अगर हमने इससे एक weight hang किया, and whatever tension is coming here in the string, that tension is nothing but equal to the reading. ठीक है, so this is spring balance. Now here spring balance is hanged from a lift. Initially lift is in rest and then it is giving how much reading? 49 Newton weight का value. तो चलो initially निकाल लेते. So initially FBD लिख लो, इस पे gravitational force नीचे लगेगा mg, upward force tension है ना, and since this is in rest, T will be equal to mg. So T is what? Tension, and this is nothing but equal to the reading value. और reading कितना दिया हुआ है? 49 Newton. It means T is equal to 49, and m is equal to how much? Nothing, not given. 9.8. Now if you are going to solve it, mass value will become 5 kg. Done. What's happening now if the lift moves downward with an acceleration of this? Agar lift downward move kar raha. Now the case is this. Let me draw it again. So again, this is the lift. This is the lift. It is hanged from here. What difference is happening? It is coming downward with what acceleration? 5 मीटर पर सेकेंड स्क्वायर. अगेन राइट द एफबीडी. ठीक है, तो नीचे डाउनवर्ड फोर्स लगेगा mg. टेंशन हमेशा अवे फ्रॉम द बॉडी लगता है, सो इट विल एक्ट अवे फ्रॉम द बॉडी t. And now t won't be equal to mg because it's coming down, so mg must be greater than t to give it an acceleration of this value. तो आप इसको लिखो mg minus t will be equal to ma. So t is equal to how much? mg minus a, and this will be the reading now. t dash ले लो, new tension, done. So new reading will be this. अब आप इसको solve कर लो. 5 into 9.8 minus 5. So this is equal to how much? 5 into 4.8. And that will be equal to how much? 24 Newton. So the answer will be what? 24 Newton. This is how we take the reading of spring balance. Just we calculate the tension. Okay. Chalo. Now this is the question. There is a particle subjected simultaneously to two SH. One along the x-axis and another along the y-axis. The two vibrations are in phase and have unequal amplitude. So चलो पहले let's see x equal to क्या हुआ? X direction में SHM है. So let's write equation of SHM in the x direction. So x equal to a sin omega t. चलो plus phi ही लिख लेते. So this is the phase of this SHM, and it is said that both the SHM have same phase. So if I am going to write the equation of another SHM along y-axis, amplitude I will write different, but since phase is same, sign है यहाँ तो यहाँ भी sign use करना होगा, because if here I am using cos, phase में changes आएंगे. Omega t plus phi. Same angle I am taking, so same function I will have to take. You same angle क्यों ले रही हूँ? क्योंकि phase is same. ठीक है, इसलिए सेम फंक्शन भी लेकर चले. सो x and y. Now whenever we need to write equation of motion and if x and y is given, what we used to do, we need to write equation in terms of x and y only. If x is given in function, जैसे if x is given as at square and y is given as at plus 2, suppose, and you have to write the equation of motion, what you will do? You will eliminate t from one place, and equation you will try to get only in the term of only as a function of x and y. तो आप first equation से t का value क्या लिख सकते हो? x by a root under, and that value you can put here. Y is equal to a root under x by a plus 2. So this will become equation of motion here. So यहाँ पे भी equation जो है time के function में दिया हुआ है, but this is more easier. Why? क्योंकि सिंपल है, टाइम तक हमें जाना ही नहीं. x by a1 is equal to how much? Sin omega t plus phi, and also y by a2 is equal to how much? Sin omega t plus phi. ठीक है, so this is equal to this, this is equal to this, so both these two has to be equal. So x by a1 is equal to y by a2. So यहाँ पे क्या दिख रहा है मुझे? y equal to a2 by a1 x, y equal to mx. So this is nothing but straight line motion, है ना? तो आंसर होगा a. ठीक है, okay. Again, this question is very easy. The height y and distance x along the horizontal plane of a projectile on a certain planet are given by y equal to 8t minus 5t square, x equal to 16. The velocity with which projectile is projected. So there is a projectile motion happening here, and it is being thrown with certain velocity. Then we have to calculate this velocity of projection. Okay, यानी कि we have to like here x is given at any time. What is the displacement? That is 60, and y is given 8t minus 5t. So from here we can calculate velocity as a function of time. Dx by dt will become 6. Similarly, here we can calculate velocity in the y direction. That is equal to 8 minus how much? 8t minus 5t square. So dy by dt 10t. Done. So this is this. Now initial velocity we have to calculate. Velocity with which projection? प्रोजेक्टाइल इज प्रोजेक्टेड, यानी कि इनिशियल वेलोसिटी, इनिशियल वेलोसिटी मींस वेलोसिटी एट t इक्वल टू 0, है ना. So velocity in the x direction at t equal to 0 is how much? 6, क्योंकि this is constant. So at t0, at t, it will remain same. Now velocity in the y direction at t equal to 0 will be what? Put t equal to 0, it will be equal to 8. So this velocity v at t equal to 0 has y component 8 and x component 6. So how much will be net value of v? तो वेक्टोरियली ऐड करेंगे, यानी कि 8 का स्क्वायर प्लस 6 का स्क्वायर प्लस 2 इंटू 8 इंटू 6, इन दोनों के बीच का एंगल कितना है? 90. सो कॉस 90 तो ऐसे भी 0 होगा. सो दिस विल बी रूट 100, यानी कि 10 मीटर पर सेकेंड. सो आंसर विल बी विच वन? सी. ठीक है, चलो. Now this is a question from which person? This is from Doppler's effect. Okay? And here you don't need to do anything. You just need to remember a formula, and then you need to draw the diagram here, whatever question is given, and then just apply the formula. अब देखो क्या है? There is a whistle of frequency 500 hertz. This is tied to the end of a string of length 1.2 meter. ठीक है, स्ट्रिंग का लेंथ कितना दिया हुआ है? 1.2 मीटर. तो आप एक काम करो, यहाँ से स्ट्रिंग को हैंग करो, यहाँ पे ये विसल है, एंड दिस इज 1.2 मीटर लेंथ, and it revolves at a speed of 40 meter per second. So here its velocity is 40 meter per second, and it is revolving in a circle. Then, so everywhere its velocity is how much? 40 meter per second. A listener standing large distance. अब देखो लिसनर एक है जो कि सपोज कर लो लिसनर यहाँ पे, ये लार्ज डिस्टेंस पे बैठा हुआ है इन द प्लेन ऑफ रोटेशन ऑफ whistle, and he or she hears frequencies of what range. ठीक है, तो अब आप देखो यहाँ पे लिसनर यहाँ है, यानी कि दिस इज द ऑब्जर्वर, एंड this is whistle that is producing sound, so this is source. If observer and source is in rest, so whatever frequency of sound source is releasing, same frequency observer will listen, but यहाँ पे source move कर रहा है. ठीक है, so here source is moving towards the observer, and here its velocity is in this direction, and here its velocity will be in this direction. So here source is moving towards the observer. Let me take 2 points. ठीक है, मैं 2 points लेती हूँ. यहाँ पे point A मान लो, ये point B मान लो. So at point A source is moving towards the observer. At point B source is moving away from the observer. मुझे range निकालना है, मतलब where this observer will listen the minimum frequency and where will it listen the maximum frequency. तो सबसे पहले डॉपलर इफेक्ट का आप क्या लिख लो? फॉर्मूला लिख. तो फॉर्मूला क्या होता है? इफ ऑब्जर्वर इज इन रेस्ट एंड सोर्स इज मूविंग, तो वेलोसिटी ऑफ साउंड डिवाइडेड बाय वेलोसिटी ऑफ साउंड माइनस प्लस वेलोसिटी ऑफ सोर्स इनटू ओरिजिनल फ्रीक्वेंसी. नाउ व्हाट इज द सिग्निफिकेंस ऑफ दिस माइनस प्लस? इफ सोर्स इज मूविंग टुवर्ड्स द ऑब्जर्वर, देन वी टेक माइनस साइन, and if source is moving away from the observer, then we take positive sign. Now you just see the new frequency is equal to this value. This value will be maximum when this denominator is minimum, and denominator will be minimum when minus sign will get included. और minus sign कब आएगा? जब source is moving towards the observer. So when whistle is at point A, it will hear maximum frequency. And when whistle is at point B, since it is moving away from the observer, here plus sign will come. Done. And in that case, it will hear the minimum frequency. So now let's calculate maximum and minimum frequency. तो देखो V का वैल्यू क्या दिया हुआ है? फ्रीक्वेंसी मिनिमम मैं पहले निकाल रही हूँ. सो उसके लिए 340 by 340 plus 40 into how much? 500. ठीक है, you will do the calculation. If max कितना हो जाएगा? 340 by 340 minus 40 into 5. So this between this and this, up to this to this. ठीक है, that will be your range. So in this question, we can see here that there is a 1 liter closed flask and it contains some mercury, right? It is, so let's first draw the flask. So it is the flask, closed hai. There is some mercury up to this level, done. And whatever space is remaining, that is filled with air, done. It is found at different temperature. When temperature is changing, the volume of air inside the flask remain the same. So initially volume of air is suppose V0, and at any temperature it is remaining V0. Done. Then we have to tell the volume of mercury in the flask. Then how it will remain constant? Volume of air. So with temperature, what will happen? Volume of flask will change. This flask volume will change and volume of mercury will change. Done. So whatever, suppose kar lo ki volume of mercury is changing by X, increasing by X suppose. And flask volume is also increasing by X. Then what will happen? Whatever increase in volume of mercury is happening, that mercury will get contained in the portion of increased volume of flask. और उस केस में हमारा एयर का वॉल्यूम क्या रह जाएगा? फिक्स. क्योंकि इफ मर्करी वॉल्यूम इज इंक्रीजिंग, इट इज नॉट ऑक्युपाइंग द एक्स्ट्रा वॉल्यूम ऑलरेडी प्रेजेंट ऑफ द फ्लास्क, है ना? What volume it will take? Whatever volume increase is happening in the flask, in the same volume, increased mercury volume is getting contained. समझ गए? So if empty space volume is not changing, it means increase in the volume of mercury is same as increase in the volume of flask. That is volume of flask. जैसे volume as a function of temperature कैसे लिखते हो आप? ऐसे gamma delta T and V minus V naught, that is volume change, will be equal to V naught gamma delta T. So this is volume change, है ना? And volume change is equal to initial volume into gamma volumetric expansion coefficient into temperature change. And this is going to be same for both mercury and flask. तो चलो दोनों के लिए ही लिखते हैं. तो क्या लिखेंगे? Volume of flask is how much? 1 liter. Now you know that 1 meter cube is equal to 1000 liter. So 1 liter is equal to how many meter cube? 10 to the power minus 3 meter cube. This is equal to this. अब आप इसको लिख लो. Volume of flask is how much? 10 to the power minus 3. Gamma of glass is how much? Alpha of glass is given. So we will convert it into gamma. Alpha and gamma is related how? So gamma is equal to 3 alpha. Alpha is linear expansion coefficient. ठीक है? तो यहाँ पे 3 into 9 into 10 to the power minus 6 into delta. And this should be equal to the same expression getting used for mercury. तो आप mercury का volume हमें नहीं पता, तो V0 लिखते हैं into gamma of mercury is 1.8 into 10 to the power minus 4 into delta T. Delta T will get cancelled. ठीक है? Now what will happen? Now you can simply solve it. तो यहाँ पे आप देख लो 10 to the power minus 6 है, ये 10 to the power minus 3 है, 10 to the power minus 9 होगा, यहाँ पे 10 to the power minus 4 है, तो इधर कितना बचने वाला है? 10 to the power minus 5. ठीक है? इतना into 9 से ये 2 टाइम्स में चला जाएगा, 2 से ये 5 टाइम्स में चला जाएगा, 5 को इधर लाओगे 15 हो जाएगा. ठीक है? 15 और कुछ बचा नहीं. So this much meter cube. वॉल्यूम इज इन मीटर क्यूब. अब इस आंसर्स आर गिवन इन सेंटीमीटर क्यूब, तो आप इसको कन्वर्ट कर लो. 15 into 10 to the power minus 5 मीटर क्यूब को सेंटीमीटर क्यूब में चेंज करने के लिए 10 to the power 6 करोगे. सो 150 सेंटीमीटर क्यूब. दिस इज गोइंग टू बी द आंसर. सो आंसर इज योर बी. ठीक है? चलो. Now this question I included just to explain how we identify strings connected in series and parallel and what are the logics we apply. Done. So what are those logics? Logic ये है कि if to whatever thing the spring is attached, you do one thing, displace the block. जैसे यहाँ पे if springs are like this and this is this block. Suppose I'm pulling this block down by distance x. So what will happen? This spring has a spring constant k1, this has k2, this has k3. So this spring, this spring, this spring, all will come down in such a way that their displacement, their sum of displacement will be equal to x. So यहाँ पे x1 लिखोगे, x2 लिखोगे, x3, and x1 plus x2 plus x3 should be equal to x. Done. If displacements are different, then we will say it is in series, and if displacement is same, we will say it is in parallel. तो पैरेलल को आइडेंटिफाई करने का सिंपल तरीका है डिस्प्लेसमेंट विल बी सेम, एंड इन सीरीज डिस्प्लेसमेंट इज डिफरेंट. व्हाट विल बी सेम? टेंशन. जैसे these are massless spring na, so massless spring is connected to mass m, and we have studied in our mechanics ki if a string is massless, if a string is massless, then throughout tension will remain same. It means here tension, here will remain same. Though their spring constant are different, their tension will be same, क्योंकि they are massless and connected end to end. That is why tension is. So in series tension is same, in parallel displacement is. अब आप एक काम करो, इस ये सारे स्प्रिंग इसी ब्लॉक से कनेक्टेड है ना, अब आप इस ब्लॉक को either upward displace करो या downward. So displace it a bit. Suppose I am displacing it downward by x. So both this k and k will get compressed by x, and this 2k will get extended by x. But modulus of displacement of all these three springs are what? Same. It means they are in what? Parallel. तो सबसे पहले आप k को parallel में add करो. You all know that the springs in parallel get added like series. So this k will become 2k. Again this 2k and this 2k is in parallel, है ना? So k equivalent here will become 2k plus 2k, क्योंकि all are in parallel, है ना? These two and this and this are also in parallel ना, क्योंकि both are suffering the same displacement down x, है ना? चलो, so answer should be 4k, हाँ ना? हाँ. चलो, now this is another thing that we read in Doppler, and this is very important. तो यहाँ पे देखो क्या इसलिए मैंने इसको include किया है. So what's the question here? There is an engine. An engine is moving towards the wall with a velocity of 50 meter per second. कितने velocity से ये move कर रहा है? It is moving towards 50 meter per second, and it is emitting a note. Means it is emitting a sound of 1.2 kilohertz. ठीक है? The frequency of note after reflection from the wall as heard by the driver of engine. So the person here, what is happening? Sound is going from here, getting reflected, coming back. So the light, the sound that is coming back to again the driver will be of what frequency? That is the question. तो कैसे approach करेंगे? Approach is like this कि देखो initially what is happening? This is the engine. This is moving towards the wall. Wall is receiving the sound and wall is reflecting. So here wall is acting like an observer. है ना? When it is acting like an observer, when engine is moving towards and wall is there, and wall is receiving the sound. So at the point it is receiving the sound, sound कौन receive करता है? जो observer होता है. So at the point it is receiving the sound, it is acting as an observer. So initially when wall received the sound from the engine, it is what? Observer. So first try to see ki of what frequency of sound it is receiving. Wall is receiving. Then, so for that it will become observer, and this is source. Source is moving towards the observer. Done. So what will be the frequency of light sound getting received by the wall? So suppose करो मैं इसको F1 बुलाती हूँ, that will be equal to F0, original frequency of the engine sound, into here source is moving towards now, and when source move towards, we take minus sign. I have discussed that question. So V by V minus Vs, है ना? Done. And this is the frequency of sound getting received by the wall. What frequency of sound it will emit? Now this is the question. Done. Because whatever frequency of sound it is emitting, it is reflecting, that same frequency of sound will get heard by, or same or different, whatever you say, क्योंकि यहाँ पे this person sitting in the engine is not in rest. सो चलो सेकेंड केस करते हैं, लेट्स नॉट कॉम्प्लिकेटेड, लेट्स मेक इट मोर सिंपल. सो सेकेंड क्या हो रहा है, लाइट साउंड इज गेटिंग रिसीव्ड, इट इज गेटिंग रिफ्लेक्टेड. ठीक है, रिफ्लेक्ट हुआ, रिफ्लेक्ट होकर वो किसके पास पहुंचा, ड्राइवर के पास. ड्राइवर इज व्हाट नाउ, who is receiving the sound, driver, so it is becoming observer, and here observer is moving towards the wall. So now observer is moving towards the source, क्योंकि now source is wall, wall is reflecting the sound, and that sound is getting received by driver. So now driver is what, observer, and wall is what, uh, producer, that is source. So this is the case of observer moving towards the source. Okay. Now, so this source is emitting sound of what frequency? This frequency. Because wall has received sound of this frequency, so it will also reflect sound of this frequency. Now, so what is the frequency of sound getting heard by driver? So chalo wo F2 hai suppose, so that will be equal to what? F1 into, that is sound getting emitted by the source, that is wall, getting reflected by wall. This is F1 frequency into, now observer has velocity towards the source. Then we will get plus sign on the numerator by, this will be our formula. Done. So this will be the frequency of sound getting received by the driver. अब इसको आप solve कर लो. F1 का value आप डाल दो. F1 का value कितना था? F0 into V by V minus Vs into V plus V0 by V. This V will get cancelled. And what is going to be the value? चलो लिखते हैं 1.2 किलो हर्ट्ज है. मैं किलो को कट नहीं कर रही. into, चलो कट कर ही लेते हैं, 10 to the power 3 into V plus V0. V is how much? 350. V0 is how much? 50. So that is becoming 400. V minus Vs. Again, that is 350 minus 50. That is your 300. So this got cancelled. This 4 by 10 tha. So 4 16, and it will 1.6 kilohertz. Then I hope it is clear. I hope. So this is this. I tried explaining so that you can understand the concept. अब यहाँ पे देखो एक क्वेश्चन था, this question was from what, thermodynamics, and what the question is, there is a carbon monoxide and is carried around a closed cycle ABC in which BC is an isothermal process as shown in the figure. The gas absorbs 7,000 joule of heat as its temperature increased from 300 to 1,000 in going from A to B. When it is going from A to B, its temperature is increasing from how much? It is increasing from 300 to 700. So यहाँ पे 300 Kelvin है, यहाँ 700 है. And it is said that BC is an isothermal. So whatever temperature is at B, same temperature will be at C. So 700. These are all in Kelvin. Okay. And gas absorbs 7,000 joule of heat in AB process. In process AB, Q value is how much? 7,000 joule. Okay. Now the quantity of heat rejected by gas during the process CA. During the process CA, how much heat it is rejected? ठीक है. तो सबसे पहले आप एक चीज देख लो, in the process A and B, work done will be 0. Let's first take the process A and B. So in process A and B, what is happening? Work done is 0 क्योंकि this is a isochoric process, volume is remaining constant. Let's apply first law of thermodynamics. अगर आप first law of thermodynamics यहाँ apply करोगे, Q equal to delta U plus W. W is 0 here. Q is how much? 7,000 plus क्योंकि getting absorbed है. Delta U can be written as NCV delta T. Now what will be the value of CV here? This is a carbon monoxide gas. CO. CO is what? This is a diatomic gas. है ना? CO is what? Diatomic. And for diatomic gas, CV value will be how much? It will be equal to 5 by 2R. है ना? This will be equal to how much? CV. This is a diatomic ना? So CV is going to be 5 by 2R. तो यहाँ पे आप ऐसा कुछ कर लो, N into 5 by 2R into delta T is how much? 700 minus 300, that is 4. तो 100 यहाँ से कैंसिल कर लो, 2 2 and 5 into 2 10, अगेन ये भी चला जाएगा, तो एन आर का वैल्यू कितना मिला है मुझे 7. ठीक है, नाउ लेट्स गो टू द प्रोसेस सी एंड ए. इन द प्रोसेस सी एंड ए, दिस इज व्हाट काइंड ऑफ प्रोसेस? आइसोबारिक प्रोसेस. If here we apply the thing Q equal to क्या लिखेंगे? फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, डेल्टा U प्लस W, है ना? और देखो यहाँ पे वर्क डन को what way we can reduce it, that thing we needed to do here, then question will get easily solved. तो आप देखो, since this process is isobaric process, PV equal to क्या लिखोगे? nRT. This is यूनिवर्सल लॉ इफ द गैस इज आइडियल. सो पीवी इक्वल टू एनआरटी. अब आप यहाँ पे पार्शियल डिफरेंशिएशन कर लो. पी डेल्टा वी प्लस वी डेल्टा पी विल बी इक्वल टू एनआर डेल्टा टी, है ना? और यहाँ पे देखो वी डेल्टा पी वाला टर्म जीरो हो जाएगा क्योंकि प्रेशर इज कांस्टेंट. पी डिवी इज वर्क डन एंड दैट इज इक्वल टू हाउ मच? एनआर डेल्टा टी. तो यहाँ पे काम करो, क्यू इक्वल टू डेल्टा यू का वैल्यू कितना होगा? एनसीवी डेल्टा टी. एनसीवी डेल्टा टी प्लस क्या लिखोगे? डब्ल्यू क्या होगा? दैट विल बी इक्वल टू एनआर डेल्टा टी. अगेन लेट्स राइट इट. सीवी को क्या लिखने वाले हैं हम? 5/2r. तो यहाँ पे एनआर को कॉमन ले लो, एनआर डेल्टा टी को कॉमन ले लो. सीवी का वैल्यू 5/2r, आर तो हमने कॉमन ले लिया है, सो दिस इज 5/2 प्लस 1, है ना? एनआर डेल्टा टी को हमने क्या ले लिया? कॉमन. सो दिस इज इक्वल टू 7/2 इंटू, अगेन आप क्या लिखोगे यहाँ पे? 7, क्योंकि एनआर का वैल्यू 7 है. डेल्टा टी इज हाउ मच? 700 माइनस 300, दैट इज 4. सो हाउ मच वैल्यू वी आर गोइंग टू गेट? 9800 जूल. सो द करेक्ट आंसर विल बी दिस. ठीक है, सो सिंपली वी नीडेड टू बी केयरफुल ऑफ दिस पॉइंट. डन. आई होप इट इज क्लियर. क्वेश्चन वाज वेरी इजी. ठीक है, अब देखो यहाँ पे कुछ क्वेश्चन बचे हैं, कीप पेशेंस. ठीक है, the metal sheet shown in the figure is with two holes cut of unequal diameter d1 and d2. If the sheet is heated, what will happen? If the sheet is getting heated and if it is a sheet of uniform dimensions and also like देखो यहाँ पे if thermal coefficient, linear thermal coefficient or aerial thermal coefficient, if that is uniform, then what is going to happen? Suppose कर लो आप यहाँ पे एक रॉड ले लो, just to understand it in simple way. यहाँ पे आप 2 पॉइंट ले लो. Now what I'm doing now, I'm giving it heat. So if I'm giving it heat and its three ends are free, so definitely after getting heat it will expand. This rod will expand, and as this rod will expand, what will happen? This point will also like this point will come somewhere here, this point will come somewhere here, because it's expanding. Done. So distance between point will also change. So if distance between point is changing, it means what is happening? Everything is expanding uniformly, right? तो यहाँ पे देखो क्या दिया हुआ है? Metal sheet shown in the figure with two holes cut of unequal diameter d1 and d2. If the sheet is heated, if the sheet is getting heated, both d1 and d2 will increase. तो आप देख लो this point, let's take this point and this point. Initial distance between these 2 points is something. If it is getting heated, distance between these 2 points will increase, है ना? Also if you are taking 2 pointers कि यहाँ पे ये ले लो, ये point ले लो, एक ये ले लो, एक ये ले लो. If we are hitting it, distance between these 2 points will increase. Done. It means diameter is increasing, right? Similarly, same thing will happen here. So both d1 and d2 will increase, है ना? So this is going to be your last question. अब यहाँ पे आप देखो question क्या था? Question is कि a uniform rod AB of length L is hinged at one end A. The rod is kept in horizontal position by massless string tied to a point B as shown in the figure. ठीक है? If a string is cut, initial angular acceleration of the rod is. Question is very simple. You just need to be comfortable with mechanics. तो आप यहाँ पे देख लो, ऐसे रॉड है. सबसे पहले चीज तो मैं ये बताना चाहूंगी कि whenever there is a hinge मतलब the point at which certain thing is fixed. Hinge applies force and in which direction? In two perpendicular direction. ठीक है? ऐसे और ऐसे. Direction you can change according to convenience. ठीक है? But always it has tendency to apply these two force but it's not necessary कि always these two forces will act. Sometimes one will be missing, other will be present. That will depend on the situation. जैसे मैं यहाँ पे दिखाती हूँ. Let's first write the FBD. So if I am going to going by convention, I am drawing two forces. यहाँ पे ऐसे, यहाँ पे hinge का force 2 डाल दिया मैंने. Tension force upward इधर and mg force downward f. अब आप देखो वर्टिकल फोर्स तो कौन कौन सा है. सपोज दिस इज n1 एंड दिस इज n2. तो वर्टिकल फोर्सेस इन अपवर्ड डायरेक्शन n1 plus t will be equal to mg. बट आप देख लो there is no other horizontal force than n2. So there is nothing that will balance it. So hinge will apply only one force, that is n. ठीक है. That is why I said कि according to your situation you will be taking the forces, but you have a scope of taking two forces like this. ठीक है. तो यहाँ पे ऐसे, यानी कि इस क्वेश्चन का एफबीडी कैसा दिखेगा. इस क्वेश्चन का एफबीडी, सॉरी आई एम वेरी बैड एट ड्राइंग थिंग्स एक्चुअली, आई हैव टू लर्न इट. बट अब यहाँ पे देखो ऐसा है, यानी कि वन फोर्स इज एक्टिंग लाइक दिस, अनदर टेंशन इज एक्टिंग लाइक दिस, and mg is acting like this. The moment we are cutting the string, tension will disappear, tension will not remain, and at that point what will be the torque getting applied around the hinge. Let's calculate. So torque, mg का torque लगेगा how much, this r cross mg. I am calculating torque around this point. So length L by 2 into mg. This is one torque. In which sense it is acting? In this. And this n1 force is passing through the point around which I am calculating torque. So tau of n1 will become how much? 0. So only torque acting is which? mg L by 2. And this should be equal to, torque should be equal to I alpha. So this rod will rotate around point A, and around point A moment of inertia क्या होगा? ml square by 3 alpha. Now you can calculate alpha very easy. Alpha will be nothing but 3g by 12. ठीक है. So our correct answer will be which one? And thank you so much. Now in whatever test comes ahead, please get yourself prepared for the test. It should not be like कि हाँ test है चले गए पेन कॉपी लेकर. No, it should not happen. You should prepare very well according to whatever syllabus is going to come. Do revise basic formulas and also get comfortable with graph as I said while discussion. Done. So a straight line and parabola graph, दो ही ग्राफ तो तुम लोगों को देखना है यार, और कुछ नहीं देखना. So get ready for that. Okay, bye bye, take care.